All right. Again, this is Mr. G Math coming to you live at 7202. It's now later in the morning, way later, 9:34 on June 29th. Now we're going to learn about another rule. So we've talked about the power rule. We've talked about the quotient rule, the product rule. Now we're going to talk about the chain rule. The chain rule is applied when we have a composite function. Do you remember what a composite function means? That one is substituted into the other. So there's a rule if you have a composite function. So I want you to see the rule there in the box, and we're going to apply it. It's really the power rule with a hook. So do you remember the power rule? We take the exponent and multiply what's in front, correct? And then what do I do with the exponent is subtract 1. But for the chain, there's going to be a hook, something you have to multiply at the end, and that's because the base is that a function that's been substituted in. So the base, you then have to take the derivative of. So if I look at number 1, if I applied the power rule, what's the exponent? 2. The base is x squared minus 3. And then what do I do with the power rule to the exponent 2? Is I subtract 1, so now it's 1. How do you know when to apply this? Is when you take the derivative of the base and it's not 1. Because if you take the derivative of a base and it's 1, times 1 doesn't change anything. But here, this is what the hook is. Look at the base. Can you take the derivative of the base? And what is it? 2x. So, just 2x, because the derivative of negative 3 is 0. This part here, the 2x, is called the hook. There's a hook at the end. It's the power rule with a hook, because the base you can take the derivative of. Okay? Let's look at it again. Do you see the big function, which is square root? And then inside the square root, there's another function. In fact, inside that square root, unfortunately, there are 2 functions. You have a square root, then you have a cube, and then inside there we have another function, right? That means we're not going to have 1 hook. We're going to have 2 hooks. So, first, I know, I feel like it's Peter Pan, right? So, in order to take the derivative, we have to write it as an exponent. So right now, I don't want square root. I want that all to the exponent 1/2. So we're going to do this. I could do this in different ways, but I want you to practice with the hook. You could also do algebra right now and make 3 to the 1/2 one exponent. When one exponent is raised to another exponent, you could write that, multiply it, it's 3 over 2, and that would take away a hook. But it's fun to have a hook. So, first hook. What's on the very outside? So we're going to put 1/2 in front. What's on the inside is 2x squared minus x to the exponent 3. And then what do I do with the exponent 1/2? Is I subtract 1, and it's now what? Negative 1/2. Cool. Next. All I did was take 1/2 in front and subtract 1. Basic power rule. Okay. Do you see what's inside? What's the derivative?
There's 2 on
yeah.
the last side, there's 3 on the other.
There's what?
2 parentheses. It does matter.
Oh.
It doesn't matter.
I got it. There's too many parentheses on the right. Got it. That's better, right? No one's calling you dumb one.
On the left.
Okay. Inside. The first hook. What do you see on the inside? What exponent? 3. So when I go 3 times what's in front of that parentheses, which is 1, you have 3, and then write down 2x squared minus x, And then what happens to that exponent? What happens to the exponent 3? Subtract 1, and now it's times. Now's the second hook. What's inside the parentheses? What's the derivative?
4x minus 1.
Done. So do you notice in this example, we had a composite inside a composite?
Calculus.
So every one inside, each one is a hook that needs to be applied. Let's look at this one.
I have a question, Mr. Gerson.
Hey, I'm here.
Comments.
Oh, I want to hear them.
Do you see how it goes from 3, 2, and then basically 1?
Mm-hmm.
Is that how it would be most times?
Well, that just has to do with the exponent, right, in terms of what's happening.
Okay.
So they're not fully connected, the 3, the 2, the 1. It just happens to be the way the question worked.
Okay.
For number 3, I don't have enough room where I'm at, so I'm going to take a separate piece of paper, and I'm going to write it over again, and I want to make sure I have room. So, I want you to notice what my first step is. I took number 3. But I rewrote it as an exponent. Are you comfortable taking the cube root instead writing it as an exponent 1/3?
Yeah.
This question involves what we just did on the last lesson and this lesson. Do you notice that there are two things multiplying here? When you see two things multiplying, you have to use what rule? The product rule. But when I take the derivative of the second, what rule do I have to use? The chain rule. So this involves both the product and the chain. Great review. And I'm here doing it with you, so there's no reason to feel grumpy about it. So here we go. How do I take the derivative of f at x? First, it's the product rule. What is the product rule? The first is what? 3x squared times. Okay? What's the derivative of the second? Do you see the 1/3? Power rule. 1/3 in front. Rewrite the base. And then what's 1/3 subtract 1? And we're not done with taking the derivative, because the base is the hook. So look at the base. What's the derivative of the base? The derivative of 9 is 0, but what's negative 4x squared? Negative 8x. Now it's done.
And that's the product rule?
The product, we're not done with the product. We're done with taking the derivative of the second.
Okay.
So the product rule is the first. Do you see how I wrote that down? This whole thing is the derivative of the second. And the derivative of the second involved the chain rule, which is the power rule, but yet you have to do the hook. What's the hook? The derivative of the base has to be included. Okay? Plus
6x.
the second.
Isn't it the first?
It's the first times the derivative of the second plus the second, which is 9 subtract 4x squared to the 1/3 times the derivative of the first, which is done.
I have a question.
Uh-huh.
You know how you said that it doesn't matter where they're at, as in like the location, because they add and multiply no matter what. But what if we do the chain rule and the product rule? Does that still apply or no?
Well, what applies is this. If you decided to take the derivative of the first times the second, then the part that's at the end would come first, and what we did at the beginning would come second.
Okay.
You still have to apply the chain rule when you take the derivative of the second. All right. Number 4.
Whoa. Lightweight.
So, This is a general formula that you're going to have to see, feel comfortable with, and practice, because there are questions like this. This is so AP-ish to have a question involving the general formula and be able to understand whether you understand the formula. So let's make sure we understand what's being communicated here. When do you use the chain rule? Is when you have a composite. Do you see the composite? Yes or no?
No.
Do you see that G gets plugged into F? Look up at the screen. I'm going to write it over again. Do you see the composite? Yes or no? That G got plugged into F. To take the derivative of a composite, you take the derivative of F with respect to G at X times the derivative of G at X. So it's the derivative of the outside times the derivative of the inside. That's the chain rule kind of in general form. The derivative of the outside. Remember when we did the power rule? That's the derivative of the outside, and the hook is the derivative of what's inside. The derivative of the outside times the derivative of the inside. In this question, this is what you're given. What's the derivative of P at Q at X? So recognize the question at the end. I'm looking at the end, and then I'm going to go back. Recognize what it's saying. Q is substituted into P. Recognize that this is a composite function. How do you take the derivative of a composite function? I'm going to go like that. It's the derivative of the outside times the derivative of the inside. So first write down the rule, the formula with only letters. The derivative of the outside times the derivative of the inside. In the question it says, use what number for x? So where there's an x, what number am I going to put in? 2. Now, inside P prime, the derivative, Q at 2. Look at the beginning of the question. Is there a number I can replace? What does Q at 2 equal?
2.
No. What does Q at 2 equal? So instead of Q at 2, what number am I going to put in? 3. How about this? What's Q prime at 2? Is that information given? Q prime at 2, what number would I put in? 2. We're almost done. P prime at 3. Look at what information you're given. P prime at 3. What number would I put in? And then all together, what's the derivative at 2? 4 times 2, and the answer is 8. It's using and beginning the beginning formula, and then taking the information in the question and plug in, until you have your answer at the end. Jerry?
Will it always be like that?
You will always be given the information you need and more information you don't need so that you actually understand what numbers you're using.
Okay.
So you'll always be given the information you need and more that you don't need to test to see you know what numbers you actually are using or not using.
Oh, I get it.
Is that cool?
Yeah.
All right. Mr. G Math, over and out.
Woo.